To start the process of growing Anabaena blue-green algae in freshwater, a fertilizer was made by collecting samples of grass, mulch, and soil from yards, soaking it for several weeks in deionized water, and then straining it to become a fertilizer from the absorbed nutrients. Simultaneously, the algae was grown using freshwater medium and sunlight until it reached 0.13 AU, or absolute absorbency units, measured with a spectrophotometer. Then 100 milliliters of each algae and the fertilizer variable were combined, covered with plastic wrap, and set in a windowsill to continue to grow. The growth was recorded over several weeks, and the difference from beginning to end will determine the results. The dry mass is also taken by weighing the results of the algae with a vacuum pump. This graph shows the first trial over the span of 12 days using the spectrophotometer. The graph shows the largest difference over this time span, and a second and third trial with additional variables of DI and medium culture are currently being set up and recorded. The support of this project was from the math teachers, Mr. Harshman and Mr. Stevenson, for providing the guidelines to follow and stay on track with the experiment. The school's funds gave the ability to purchase the algae, medium, and pre-existing supplies such as the Erlenmeyer flask, a spectrophotometer, and the vacuum pumps and additional machinery. Additional support came from peer-reviewed educational sources such as Penn State and the Environmental Protection Agency, which gave support of the hypothesis of grass fertilizer being the most effective growing agent. The Sarasota Water Atlas gave information on the drains and the common contents within them, such as the grass and mulch and dirt. Additionally, previously experiments measured with algae growth using a spectrophotometer and the dry mass was used as a guideline to base the procedures off of. Strengths of this project include the ability to isolate the variables and have consistent time periods to measure the algae with the spectrophotometer and make observations. The fertilizer solution was the same for each trial, and the levels of each step were measured. This project is able to be completed affordably and with a reasonable time. The location of growing the algae was positive because there was artificial light half of the day, along with sunlight from the window, and a cycle of darkness at night for both. Weaknesses of this experiment, however, which would be corrected in additional experimenting, is the first trial did not include the deionized water or medium variables. It was just not thought up yet, and so it was a better idea to add it on to have these trials for future comparison results. These trials 2 and 3 will give better comparisons for the results and how the yard material was beneficial to the growth. Another weakness is the slight inconsistency of measurements because the experiment took place at a school, and there were some days which the presence was absent or the school was closed for a day. But this was made up by collecting data when returned to the additional variables for the 2 trials and provide evidence for the conclusion, and the data was collected right when returned to school. The real-world application. So the main issue associated with the project is pollutants from yards on the coast. Living in Florida, there are many homes built near drain systems or directly on the water. These drains are transporting pollutants into the ocean and causing algae to bloom. One pollutant found in natural materials such as mulch, dirt, or grass is fertilizer. The algae blooms of red tide are much affected by these fertilizers, such as potassium and phosphate and nitrogen. While algae is necessary for the balance of the food chain, it can also cause destruction when they overpopulate. And by mimicking the blue-green algae growth in drains, fertilizers from natural agents are observed and to see which yard material is the worst for the ocean balance. And the unexpected outcomes, while I knew phosphate and nitrogen are agents which can cause algae blooms and ocean pollution, I did not know the extent of the natural agents contributing to the overpopulation as well, such as like things that come from your own yard. Before researching, I would have thought soils hold the most nutrients in yards. However, multiple sources confirm that Penn State's article saying grass clippings returned to the lawn provide up to 25% of your lawn's total fertilizer needs. And grass clippings contain about 4% nitrogen and 2% potassium and 1% phosphorus. The second trial had similar data to the first. However, trial 3 is growing at a faster rate than trial 1. This is another unexpected outcome, but it is not fully concluded yet. Further communication and results will be shared moving forward with this experiment, and I hope to tell you about it. Thank you.